Okay, here's a hint for your homework number 4, free series, DTFT. So I choose some problems from your homework problems. They're similar, but not exactly the one in your homework. But I'm going to show you some hint how to solve the problems in your homework. Okay, first one is from 4.3. So we use question B as example. Here we have a signal xn. Xn is odd number, so that odd symmetric. So that means xn equals to minus x minus n, odd symmetric. So we calculate DTFT like this. Since we have xn odd symmetric, so we can divide x into 3 different portions. First of all, it's the negative portion, right? Because it's all symmetric, so we can write down 1 to infinity. And here, we should have x minus m, but it's equals to over here, right? Because all symmetric, so we have minus xm e j omega m plus x0. So this is the second portion, just at origin point. Here we have the positive portion, xn e to minus j omega n. And we know, right, those two are the same because of odd symmetric. So the second portion goes over here, x0, and we combine the first and the third parts together. So we have xn e to minus j omega n minus e j omega n. Look at this one. We have sine. So we have 2j sine omega n. So now we kind of solve problem number 1. Okay, second, 4.4, we use D as example. So if we know 0.5 to n un, the Fourier transform is given from your table. It's 1 over 1 minus, right, the number 0.5 e to minus j omega. Okay, you can simplify it like this, and you can just leave it as this one is also okay. Now we want to use properties in DTFT to solve the following questions. Now we have n times 0.5 un, 0.5 to n un. So this is multiplied by n in time domain. So we know the property we should use is differentiation in frequency domain. So now we have j d omega, right? We just use the previous one, we just omitted over here. So we calculate differentiation of this part, we get the answer for it. Okay, next we use property one more time. So compare with the previous one we just calculate. We have cosine 4n times the entire sequence. So any sequence time cosine, we use another property similar to frequency shift. So the entire Fourier transform will be moved to 0.5, 4, right? 4 and 4. So plus 4 and minus 4 for omega, and also half. You can find the property in the table I gave you from Blackboard. Okay, next, actually we still use properties to solve this problem. So if we know Vn is n times xn, we want to calculate V omega based on x omega, right? So this is the property we use just as we use for problem 4.4. So n times a sequence in time domain. First domain we have differentiation for your Fourier transform. Okay, x omega is given, right, from the problem. So d omega of it, we have the final answer of it. So problem 4.4.5 give us some hint how can we use existing pairs and Fourier transform properties to solve the problem. So like differentiation, right? Differentiation, and also frequency shift. 4.7, we use part B as example to show you some hint. So this time, we know Fourier transform. Want to find the inverse Fourier transform. So generally, we can use, I guess, write that as 1 xn is 1 over 2 pi, right? Minus pi to pi x omega ej omega n d omega. Okay, so if we have a sequence, this is the way we calculate xk. Definitely we can use fast Fourier transform is more efficient and quicker. Okay, so this is the equation we can use. However, calculate integral is not so easy thing to do. So here we have another method you can use. We call it inspection. So this is the method we're going to use. We just expand cosine omega by using the rule equation. So x omega we rewrite it as half ej omega plus e2 minus j omega. So by using the rule equation, now you can find the coefficient before ej omega, that is x1, and the number before e2 minus j omega, that is x minus 1. So we get inverse Fourier transform x minus 1 equals x1 equals half. Okay, all other points equal 0. So we use inspection method previously a lot in finding out a Fourier series. This is similar method, but a different problem. Okay, last hint I want to show you is from problem 4.9. We use B as example. So we know a sequence xn. Try to find xk. We only have 4 points over there, right? So here is the equation we are going to use. Definition for xk. So n from 0 to 3, right? Because capital N is 4, right? We have 4 points. So n from 0 to capital N minus 1, that is 0 to 3. Okay, as xn, here is e2 minus j 2 pi, capital N, right? Lowercase k, lowercase n. Now xn we know, right? 1, 0, minus 1. We just substitute all the value here. So this is first number xn, n is 0, right? Here, x1, x3, right? x2, this 0, right? So that's so we have xn when n is 0, right? xn when n is 2, so only those 2 points. The other 2 points we get 0. Okay, now we simplify it. We get this one. And k will be from 0 to 1, 2, and 3. So we can find x0, x1, x2, and x3. We get 0, 2, 0, 2. So this is example how we calculate xk.